What's up everybody? In this lesson, we are picking up right from where we left off with conditional statements. If you missed the previous lesson, make sure to catch up on it. We are also going to write a Python application that calculates a student's grade based on the score entered. Without further delay, let's dive in. Just like if, else is also a keyword in Python. This means when the first condition is not met. In other words, when it is not true, you want to do something different. This block of code will only run if this condition is true. If it is not true, this part of the code will be executed. Let's jump into the code editor and practice this. Let's declare two variables, x equals 10, y equals 20. If x is greater than y, print x is greater than y. This is the line of code that is going to run if this condition is true. If the condition is not true, we want something else to be executed, and that is why we need the else keyword. Type else keyword followed by a colon, then press enter on the keyboard. Notice that in the next line is not starting from the very beginning. Print x is not greater than y. If this condition is not true, we want something else to be executed, and that is this line of code. The expected output is this line of code because x, which is 10, is not greater than y. If this condition is false, then this line of code will be executed. Let's run the program and see the output. Great. X is not greater than y. Let's modify the variable x to be greater than y by writing 50. 50 greater than 20? Yes, the output is true. That means this line of code will be executed. Let's try and run the program again and see the output. X is greater than y. Essentially, you make use of the else keyword if you want a block of code to be executed when an initial condition is not true. Let's try one more example by using a list. List underscore a equals a list of strings. If a, which is a string, in list a, print a is in list underscore a, else print not found. We are establishing a condition here which is going to evaluate to either true or false. A in list A, that is string A present in list A, the answer will evaluate to either true or false depending on whether string A is present in list A. A in list A, the answer will be true. That means this line of code will be executed. If this condition is not true, that is if string A is not present in list underscore A, the result will be false, and that is why this line of code will be executed. Let's try to execute the program. The output is string A is in list A. Let's try and modify this to be D. D in list A, the answer will be false because D, which is a string, is not present in the original list, which is list underscore A. That means this line of code will be executed. So now let's run the program again and see the output. The answer is not found. The elif keyword in Python allows us to perform an additional check in case the first check is not true. It is a way of saying if the previous condition is not true, then try this condition. If this condition is not true, then try this condition. Else, if none of the conditions is true, then execute this. Let's use a grade system as an example. Grade equals A. If grade equals A, print excellent. Elif grade equals B, print very good. Elif grade equals C, print good. Else print grade not found. The first condition is to check if grade is equal to A. If this check does not evaluate to true, then we want to try another condition by using elif. Elif grade is equals to B, then this line of code will be run. We can use as many elif statements as needed. If this condition is not true, that is, it does not evaluate to true, then we want to try another condition, which is grade equals C. If none of the conditions is true, then the else block will be executed. If grade equals A, execute this. Elif grade equals B, execute this. Elif grade equals C, execute this. Else, that is, none of the conditions is true, then execute this line of code. Let's try and execute the program to see the outputs. The output is excellent because grade is A. Now let's modify grade to be B. Save the file and run the program again. The output is very good because grade is equal to B. So now let's try to use K. The expected output here is grade not found because none of the checks is true. Let's execute the program. Great, the answer is grade not found. One point to note is that if any of the conditions is true and its block is executed, then the rest of the conditions would not be checked. Alright friends, so let's start writing the grade calculator app. The first requirement is to display a welcome message to the user. After that, we need to accept the user's input. Once a user provides an input, we need to validate what the user provides because we cannot always trust the user's data. After that, we check where the user score falls. And finally, we display the grade. We can use the print function to display something on the screen. We are just going to write print grade calculator. Print this app computes grade based on score. To ask the user for a value, Python provides the input function for this purpose. We need to declare a variable to store what the user provides. User underscore score underscore input equals inputs, enter your score. The string inside the input function is optional. It is meant to be displayed before a user inputs a value. The value from the user is captured and stored in this variable, which is user underscore score underscore inputs. For now, let's print out what the user has entered. Now let's run the program and see the output. Let me enter 90, then press enter. As you can see, the user provided input is printed to the terminal by using the print function. Regardless of the data type entered by the user, the input function always converts it to a string. Let's confirm that. Print type user score input. The expected output should be string because the input function converts anything to a string. Now let's run the program. Enter your score. I'm going to enter 90 again, then press enter on the keyboard. Despite entering a number, the returned value is a string. The next step is to check if the user enters a positive whole number. This can be done by using the isDigitString method in Python. This method returns true if all the characters in the string are digits. If user score input dot isDigit print valid number, else print invalid number. The isDigitString method returns true if all the characters in the string are positive whole numbers. Otherwise, it returns false. Now let's run the program again to see the progress. Enter your score. If I enter P, which is actually not a number, we are getting invalid number. So let's run the program again by imputing a valid whole number. Press enter on the keyboard. Great, this is a valid number. The next thing to do is to take the user score, which is a string, and turn it into a number. This is important because we want to do some math with it. I'm just going to declare a new variable score equals float because I want to convert user score inputs to a float number. Then after this line, I'm going to check where the score falls. If score is greater than or equals to 90, grade, which is a new variable, equals A. We can make use of elif because we want to do some further check. Elif score greater than or equals to 80, grade should be equals to B. Elif score greater than or equal to 70, grade should be C. Grade equals C. Elif score greater than or equals to 60, grade should be equals to D. Else, that is, none of the conditions is true, grade equals F. After all the checks, what we want to do is to print out a message to the user, a string. Your score is the score, which is the variable we declared up here. Your grade, the grade. Alright, I'm going to briefly explain this line of code again. The first part is to print out a welcome message to the user. After that, we collect an input from the user, and the input collected is saved in another variable. The next part of the code is to check if the value provided by the user is a digit, and that is why we are using the string isDigit method. Remember, anything entered by the user is a string because the input function returns a string. This isDigit method is either going to return true or false. If all the characters in the strings are numbers, then this block of code will be considered. If you've noticed, there is another if statement inside the original if statement. This is known as nested if statement. On this line of code, we are converting the original score, which is a string, to a number because we want to do some math. After that, we are checking the score, which is a variable we declared here, against some set of values. If score is greater than or equals to 90, this line of code will be executed. If this is not true, then another check will be done, and so on. If all the conditions are not true, then F will be assigned to grade. The next line after the else block is print statement, which is printing to the terminal the score of the user and the grade. Once a block is executed, control is returned to the line immediately after the check, which is this line. In this case, this line won't be executed. That means the next line that will run in the program is this line on line 22. Print end of the program. Let's execute the program. Enter your score. I'm going to press 80. Your score is 80. Your grade is B. End of program. Let's execute the program again while using an invalid number IO. Press enter on the keyboard. Invalid number. End of the program. If we enter a decimal value such as 22.4, the isDigit method won't regard it as a number because of the dots. To handle such cases, we can improve this solution by using a try and catch approach, which we haven't covered yet. For those curious about how this could be done, please check the description section of the video. The ternary operator is a simple way to make decisions in Python. It takes a condition. If the condition is true, it returns the value on the left hand side. Otherwise, it returns the value on the right hand side. Let's try out an example. Age equals 10. X equals if age is greater than 10. This is the condition. If age is greater than 10, this should be returned, which is the value on the left hand side, old. Else, this should be returned, which is young. Now, let's print X. So the question is 10 greater than 10. The answer is false. This means this part of the code will be returned. Let's execute the program. Great, the answer is young. Now let's try to use 15. You cannot say 15 greater than 10. Yes, the answer is true. That means this part of the code will be returned. So the expected output is old. Let's run the program again and see the output. Great. This is particularly useful when you need to choose between two values based on a condition without writing a full if-else block. That's all for now. Thanks for watching and see you in the next video.